Hello, smart scholars. This is Dr. Eve Mboso. So today we are going to be looking at the biosynthesis of cholesterol. Cholesterol is an important compound that is found in all cells. All cells are surrounded by cell membranes, and the cell membranes have cholesterol as a major component. Now, what happens is that cholesterol maintains the structure and the integrity of the cell. Cholesterol is also a precursor for bile acid, vitamin D, and also a precursor for steroid hormones like progesterone, estrogen, testosterone. These are all compounds that are synthesized from cholesterol. Cholesterol plays a major role in steroid hormone biosynthesis. So now let's look at the compound cholesterol. It's a 27-atom carbon compound, and beginning from here, all right, this is carbon 1. These joints are carbon atoms. So now from carbon 1, carbon 2, carbon 3, you at this point, you have this functional group, this hydroxyl group. Then this is carbon 4, carbon 5, and 6. So between carbon 5 and 6, you have the double bond. And then you now go down to carbon 17, and then you have carbon 25, 26, and 27. So we are going to look at the biosynthesis of this 27 carbon atom. And we are going to see that the source of the synthesis of this carbon atom is from this 2 carbon atom called acetyl-CoA. I'll just write it down. Acetyl-CoA. So acetyl-CoA serves as the source for the synthesis of this biochemical compound. So you can see from here that acetyl-CoA is a 2 carbon atom compound, and then you have 27 carbon units making up the cholesterol structure. So that tells us that the biosynthetic pathway is a lengthy one. But we are going to concentrate on the major components, important components, because it's such a long biochemical process. But cholesterol is an important compound, and so that's why we have to look at the biochemical process. So now, beginning from acetyl-CoA, where do you get acetyl-CoA from? Acetyl-CoA can be gotten from beta oxidation of fatty acids, but acetyl-CoA can be gotten from the glycolytic pathway. That's where pyruvate is oxidized. And then acetyl-CoA can also be gotten from ketogenic amino acids. Now, these reactions occur in the cytosol, where beta oxidation of fatty acids, oxidation of pyruvate. Now, when acetyl-CoA is formed in the mitochondria, something happens. It moves from the mitochondria to the cytosol. Now, let's go on. Now, beginning with acetyl-CoA, when you have a condensation, of 2 acetyl-CoA molecules, all right, you have the formation of acetyl-CoA. Now, what happens here, I'll write this clearly so that we can look at it, acetyl. So the condensation of 2 acetyl-CoA molecules gives rise to acetyl-CoA. And what happens, you have a loss. So if you look at the direction of the arrow, so a loss of 1 CoA molecule. And this reaction is catalyzed by thiolase enzyme. Remember, in biochemistry, any compound that ends with the ASE is an enzyme. All right, let's continue. From acetyl-CoA, we now have the addition of another acetyl-CoA molecule. And then you now have the loss or the removal of 1 CoA molecule, which will lead us to the formation of HMG-CoA. Now, this compound, all right, this is an abbreviation. You can call this 3-hydroxymethyl-glutaryl-CoA, or HMG-CoA. Now, the next step all right? It's a very important step in this, all right, pathway. By the way, this reaction, okay, is catalyzed by H, all right, so I'll just write this down so that we get it. It's catalyzed by HMG-CoA synthase. HMG-CoA synthase. So after you have the formation of HMG-CoA synthase, we have a very important compound which is catalyzed, which leads to the formation of mevalonate. Mevalonate is a very important compound in the cholesterol biosynthetic pathway. Now, this compound, all right, is catalyzed by a very important enzyme, otherwise known as the rate-limiting enzyme. Now, the rate-limiting step is the step that controls the metabolic pathway. Now, HMG-CoA is catalyzed by the enzyme HMG reductase. And this enzyme is highly dependent on NADPH. All right, so now mevalonate is a very important compound. This is the rate-limiting step in this reaction. In fact, it controls the rate at which cholesterol is synthesized. A high level of cholesterol, all right, can be controlled. Or excessive amounts of cholesterol in the body can be controlled by the regulation of this enzyme. All right, statins that are used or given in the hospitals, all right, to lower cholesterol levels. Their biochemical reaction or mechanism of action is by acting on this or regulating the HMG, all right, CoA reductase. Now, from mevalonate, we begin to have a series of condensation reaction. So I'll just draw this up. I'll take this up, all right, and then we'll have isopentyl, all right, units. So we have a series of condensation reactions, all right. So you have isopentyl units, and then from there, you now have isoprene units, a series of reactions. Remember, this is just a two, all right, carbon atom that is metabolized to give us this giant molecule. So it's a series of steps, but we are paying attention to the, all right, most important steps, all right. So we have the condensation reaction, the formation of mevalonate, and then we have the isopentyl, all right, the formation of the isopentyl unit, where you begin to have the combination, all right, or the condensation reaction. Now I'll take this off, all right. So you have isoprene, all right. From isoprene, you will have another important compound called squalene. Squalene, all right, is a compound that is formed in this metabolic pathway, and it plays a role, all right, in forming the cholesterol unit. So now from squalene, you have the formation of the sterol, beginning of the formation of the sterol compound. And from squalene, you have lanosterol. So you have the enzyme, all right, squalene synthase. Now from lanosterol, you have 7-dehydroxycholesterol, and then from 7-dehydroxycholesterol, we have the formation of cholesterol. So I'll just take us over these steps again. You have the condensation of acetyl-CoA, catalyzed by the enzyme thiolase to give us acetyl-CoA. Then you have the formation of HMG-CoA, and then you have the formation of mevalonate, which is catalyzed by HMG-CoA, reductase. This is the rate limiting step in this reaction and is highly dependent on this compound, NADPH. Now you have, from mevalonate, you have a series of condensation reaction that will lead to the isopentyl, units, isopentyl units, and the isoprene, and then you have squalene, and then you have lanosterol. From lanosterol, you have the formation of 7-dehydroxycholesterol, and from 7-dehydroxycholesterol, you have the formation of cholesterol. So note the rate-limiting step, the source of acetyl-CoA from beta oxidation of fatty acid, beta oxidation of fatty acids and amino acids, and oxidation of proteins. Now, cholesterol in its free form is what you have here. But cholesterol must be taken up by the cells. And at that point, cholesterol esters are formed, where fatty acids are added to this hydroxyl group of cholesterol to make it more hydrophobic. So cholesterol is stored, as cholesterol esters. And there are certain enzymes that are responsible for the conversion of cholesterol to cholesterol ester, and that is the cholesterol acyl transferase. What it does is that it transfers a fatty acid group component to this part of cholesterol, and where it is stored for further use. And it's also responsible for ensuring that the levels of cholesterol are not over elevated within the cells. Now, cholesterol, having been formed at this point, remember that cholesterol has 4 rings. You have the A ring, the B, the C, and the D ring. So this is what the active form of cholesterol, where you have this, and then the inactive form of cholesterol is cholesterol ester, where this cholesterol is attached to fatty acid component and is stored within the cell. All cells, have the receptors for cholesterol, express the receptors for cholesterol biosynthesis. But there are certain cells that have a high level of cholesterol synthesis. These are the liver, the adrenal, and the gonads, that's the ovary and the testes. And then during pregnancy, you have the placenta. These enzymes have a high rate of uptake of cholesterol and cholesterol biosynthesis. So that's all for this, and make sure you drop your comments in the comment section below. Enjoy your stay as you watch this video. Bye-bye.